Okay, this is section 4.8, complex numbers. And what we're going to do in this section is we're going to multiply and simplify complex numbers. That's our objective here. Okay. Previously we added and subtracted. Now we're going to go through and we're going to look at multiplying complex numbers. Now, there are some steps here that as we look at, okay, we got four things that we're going to look at here. Number one says if it is two monomials, you simply multiply each term together and then you simplify what you have. Okay. Number two says if there is a monomial times a binomial, then you will use the distributive property and simplify. Number three says if there's a binomial times a binomial, then you will use the FOIL method and simplify, and we'll kind of hit on that a little bit. Just to remind you what the FOIL method is. You have had that before. And then number four says remember that real numbers and imaginary numbers are not like terms and that we cannot combine them together. That's a little reminder from when we added and subtracted. When we have a real number plus or minus a imaginary number, we cannot put those together. We can multiply them, but we cannot add and subtract them. Okay. A couple things I want to discuss here. We talked about in the last section what I was, and if you remember, I is the square root of -1. Okay, and that's what we gave. The value of I is the fact that it's the square root of -1. Now, a couple of things that we are going to look at here in terms of when we multiply, we got to simplify things. So, if I were to take I and square it, we want to look and see at what we would get in that case. Now, remember, I squared is I times I. Okay? Or if I wanted to rewrite this, I could say I squared, instead of I could say I is the square root of -1, and we want to square it. Now, what happens to the square root and the square? They cancel each other out. So I squared happens to end up being a value of -1. This is important to remember when we simplify. Anytime you see an I squared, you're always going to replace that with a -1. Okay? Okay, so let's take these examples now and let's take a look at them. Again, anytime you have two monomials are one-term items, binomials are two-term items. So if I have a monomial times a monomial, I'm just going to multiply. A monomial, one term times two terms, I'm going to distribute. Okay, and if I have a binomial times a binomial, I'm going to use the FOIL method. Okay, so as you look at example number one here, simplify the following expressions. Okay, so I see two one-term items. All right, so again, I'm going to take 7i times 3i, which 7 times 3 happens to be 21. And I times I, again, is I squared. And if you remember from previously, we said that I squared has a value of -1. So anytime I see I squared, I'm going to replace I squared with a -1. So this really, in problem number one, is 21 times -1, which happens to be -21. Okay? So when you're multiplying monomials, it becomes a little bit easier. Okay? Now, number two is a monomial times binomial. Here we're going to use the distributive property. So I'm going to distribute this this 3i times -5 and 3i times 2i. So 3i times -5 is -15i. Plus 3i times 2i, 3 times 2 is 6, I times I is I squared. Okay. Remember, anytime we have an I squared term here, we're always going to make that -1. So really this is -15i Okay, so this is -15i plus 6 times -1. Well, 6 times -1 is -6. So this is really -15i minus 6. Okay, now we never want to leave it with the imaginary term first. The real number always comes first. Remember, it's a plus b times I. A plus or minus b times I. Okay? So as we look at this, the real term always comes first, so I'm going to switch these around and make this negative 6 minus 15I. Some may ask, is this a big deal? Absolutely. If you leave your answer in this context right here, that's going to be wrong. You got to flip them. Real number always comes first. Okay? So there's an example of distributive property. Now we're going to look at an example of two binomials. Okay? And anytime we have two binomials, we're going to use the FOIL method. So when we do this, we got first times first. 4 times negative 1 is negative 4. Outsides, 4 times negative 2i is negative 8i. Insides, 3i times negative 1 is negative 3i. And last, positive 3i and negative 2i is negative 6i squared. Okay? Now we're going to combine our like terms and simplify our expression. So we've got like terms right here. So I've got negative 4 minus 3 and negative 8 is negative 11i. And remember, this is negative 6 times negative 1, which makes this negative 4 minus 11i plus 6. And if you'll notice, when you have an I squared, essentially what's it going to do? It's going to change the sign. Okay, so now I combine my like terms 6 and negative 4. 6 minus 4 is 2 minus 11i. And that's your final answer. Again, your real term comes first, your imaginary term comes second. Okay? All right, let's take a look at number 4. Again, we have two binomials, so we've got to use the FOIL method. I go first times first. Negative 6 times negative 6 is positive 36. Outsides is going to be plus 6i. Inside is going to be minus 6i. And last is negative I squared. Okay? So I've got these two are like terms, and those happen to be 0. So 36 minus I squared is negative 1. So I'm always going to replace I squared with negative 1. And then because I have two negatives here right next to each other, this is going to become 36 plus 1, which is 37. Okay. So again, a lot of this stuff really isn't going to be that horribly new to you. The only thing that's really new in this concept would be the I squared being negative 1 and you having to replace it. Okay. All right, let's go to the next page and let's take a look at the next examples. Okay, so now we have a couple more examples here. One more example. Okay, a couple of examples of FOIL. Okay, so we look at number 5 here. If we go first times first, we get 8. Outside, we get 10i. And inside we get negative 12i. And last we get negative 15i squared. Okay, so again we're going to combine our like terms and simplify here. So 10 and negative 12 is negative 2i. And this right here, negative 15 times negative 1 essentially becomes plus 15. It's just going to change the sign. So now 8 and 15 are 23, and so I've ended up with 23 minus 2i. Okay, and that's your final answer. Okay, number 6. Number 6 looks a little bit differently because now we have a quantity squared term. Now, if you remember from before, I said x squared is the same thing as taking x times x. So 4 minus 2i squared is going to be the same thing as taking 4 minus 2i times 4 minus 2i. There's two of them. And now we FOIL. So first times first is 16. Outsides is negative 8i. Insides is negative 8i. And last is positive 4i squared. So now I combine my like terms. So I've got 16 minus 16i, negative 8, and negative 8 is negative 16. And then minus 4. Again, this I squared changes this sign. Okay? So now 16 minus 4 is 12 minus 16i. Okay? All right, let's take a look here at the last problem then. Problem number 7. Okay? Problem number 7, a little bit different. We've got 3 sets of parentheses now. So what I'm going to do is I'm just going to take these first two steps of parentheses and I'm going to multiply them together. Monomial times monomial. 8 times 2 is 16. I times I is I squared. And I have that times 5 plus 3i. Okay? Now, remember, I squared is negative 1. So this now becomes essentially negative 16 times 5 plus 3i. Remember, 16i squared becomes 16 times negative 1, which is negative 16. And now I'm just going to distribute. Negative 16 times 5 is negative 80. And negative 16 times 3 is negative 48i. And that's it. You're finished. Remember, you can't combine these two terms here because they're not like terms. I is just like a variable, in other words. Okay? All right, this concludes section 4.8, multiplying complex numbers. Our next section is going to move into dividing complex numbers.